Hey there, I'm Radian and welcome back to my channel. This is the 5th video in our series building a React guitar theory app. So far we've created a fretboard with various scales and implemented the Cage system's 5 basic open chords. Today we are adding arpeggios to our caged page, a natural progression since arpeggios break down chords into individual notes played sequentially, helping guitarists understand chord construction while developing technique for melodic playing. You can find all the source code in the GitHub repository linked in the description below. To implement switching between chord and arpeggio views, we'll define a type-safe union of the two views using TypeScript. We'll create a constant called caged views that's an array containing the strings chord and arpeggio, and then define a caged view type that can only be one of these two values. Next, we'll leverage Next.js dynamic routes to create our caged page with switchable views. This pattern generates separate static pages for chord and arpeggio views at build time, improving performance. We'll use getStaticPath to generate roots from our caged views array, while getStaticProps passes the current view to our caged page component, enabling view-specific rendering. To manage state for our caged component, we'll implement a React context for tracking the current view. The getValueProviderSetup utility from RadionKit is a small helper that simplifies creating single value providers by handling the context creation, provider component, and hook generation in one concise function. The resulting caged provider wraps our page component to make the selected view available to all children without prop drilling. Additionally, we'll create two utilities. MakeCagedPath generates URL path based on state, while useChangeCaged provides a convenient hook for navigating between views by updating the URL. Our page structure uses a caged provider to wrap the entire caged page, creating a shared context for view state. The page layout consists of three main components: a manage caged view component for switching between chord and arpeggio views, a caged page title, and a responsive grid of caged item components displayed in a horizontally stacked layout. For our view switching interface, we implement a manage caged view component that leverages the grouped radio input component from RadionKit to create an intuitive toggle between chord and arpeggio views. To ensure consistent SEO across our application, we'll create a caged page title component that dynamically generates page titles and descriptions based on the current view. This component pulls the view state from our context, capitalizes the view name, and uses the match utility for view-specific description text. To render each chord or arpeggio shape, we map through the caged chords array, rendering a caged item component for each chord position. The caged chords is a constant array containing the strings C, A, G, E, and D. To represent the precise location of notes on the guitar fretboard, we define a note position type with two key properties: a zero-based string index and a fret number. The fret value uses a specific convention where -0 indicates an open string, 0 represents the first fret, and so on. We'll use the open caged chords and caged arpeggio objects to store the note positions for each chord and arpeggio shape. The C and G arpeggios can be played in the same position as their corresponding open chords, maintaining their familiar low position fingerings. However, the A, E, and D arpeggios contain notes that would extend beyond the guitar's physical limitations if playing in open position. To address this, we shift these arpeggios one octave higher, placing them around the 11th and 13th frets, where all notes can be comfortably reached within a single hand position. Now let's look at how the caged item component renders each chord or arpeggio shape with proper highlighting of the root note. For better visual identification, we need to distinguish the root note from other chord tones. The component calculates the lowest bass string by filtering all positions to find notes that match the chord's root note value, then determining which of these is one of the lowest bass strings. This root note is then rendered with the primary styling to provide consistent visual anchoring across both chord and arpeggio shapes. The actual rendering of notes on the fretboard uses our custom fretboard and note components, which handle the visual representation of string position, fret markers, and note indicators. The component also calculates the visible fret range to ensure all notes are displayed clearly with a minimum of 4 frets shown. For a deeper understanding of how these fretboard visualization components work, check out the first video in the series where we established the foundational rendering system. You'll find that linked in the description as well. That wraps up today's video on implementing arpeggios in the cage system. If you found this helpful for your guitar learning or React development, please hit that like button and subscribe to the channel for more videos on web development and guitar theory. Drop a comment if you have any questions about the implementation or suggestions for future videos. Thanks for watching, and I'll see you in the next one.